All right, so 7.1 is called linear and nonlinear systems of equations. So we start with like, what is a systems of linear equation? A system of linear equations is two linear equations. So you're going to have two equations, two variables. When we get into nonlinear, so these are going to be two lines, right? And then when we get into nonlinear, one could be squared or one could be cubed, something like that, in which you could have a parabola and a line. You could have two parabolas, that kind of stuff. That would be the nonlinear. So a solution to the system of linear equations in two variables is an ordered pair that satisfies both equations in the system. So answers here are going to be xy coordinates. And if you got to your answer, so this says determine if the ordered pair -1, 3 is a solution to the system. If you wanted to work backwards and check, then what you would have to do is take that coordinate point, which is going to be your x and your y, and you're going to plug it into both equations. So in order to check to make sure it works, it has to work for both. So I would get 2 times -1 minus 3 equals -5. 2 minus 3 equals -2. Minus 3 equals -5, and -5 equals -5. So it works for that one. And then you'd have to check the second one. So -1 plus 3 equals 2. 2 equals 2, and it works. If it works for both, it is yes. This is an ordered pair that would be a solution to the system. If it worked for one and not the other, it's a no. So it has to work for both. This is obviously not a test question, but this is how you could check your answers on these kinds of things. If it was like a standardized test in which you had multiple choice and you had no idea how to solve it, you could always take your answers and plug them in and see which one works. You just got to make sure it works for both equations. All right, so there are three. We are going to, three. We're eventually going to learn 5 ways to solve systems of equations. But the first is by graphing. So if it asks you to solve systems of equation by graphing, the solution of the system of linear equations can be found by graphing both the lines on the same graph and then identifying where they cross. So if these two lines were my system of equation and I wanted the solution, it happens where they cross there at 4, -1. 4, -1 would be my solution. So if it says to graph, because we're going to learn 3 different methods in the next 2 days, we're going to do graphing, we're going to do substitution, and we're going to do elimination. If it says to graph, you have to graph these. You can always check it using a different method, but you have to graph them. If we're solving using substitution, then we're going to solve one equation for one of the variables. We're going to plug that expression into the second equation in place of the variable, solve for the remaining variable, and then plug it back into the original. There are 2 special cases here. And that is one, well, in both cases, both variables cancel out. If both variables cancel out and what's left is a true statement, for example, 0 equals 0, then my answer is all real numbers. Any pair would work in that equation or in that system. If all the variables cancel out and what's left is a false statement, then it's no solution. So if I had something like 1 equals 0, obviously that's not a true statement. So that would be a no solution. All right, so specifically this one says solve by the substitution method. So I'm going to pick one of the equations, I'm going to isolate one of the variables, and then I'm going to plug it into the other one. Sometimes there's an easier route to take, and sometimes it's like equally difficult. So kind of look at both equations. Is there one that would be easier to isolate a variable?
The second one?
What would you isolate in the second one? So you'd have to do -x, and then you'd have to multiply by -1, but that works. Is there a variable that's easy to isolate in the first one? Y, right? Y doesn't have a coefficient. So if I take the top one and I solve for y, I would subtract the 5x. and I get y equals 9 minus 5x. Then I take what y equals and I plug it into the y on the second equation. And I get negative x plus 3 times what y equals, which is 9 minus 5x equals 11. I would distribute the 3, negative x plus 27 minus 15x equals 11. Combine my like terms, negative 16x plus 27 equals 11. Subtract the 27. Negative 16x equals negative 16. Divide by negative 16. And x is 1. With me so far? Now I take that 1 and I got to plug it back in. I can plug it back into either original, or I can plug it back into the one I already solved for the other variable, which means y is already isolated. So if I do that, I get y equals 9 minus 5 times 1, y equals 9 minus 5, and y equals 4. So usually it's easier to plug into the one you solved. I would say if there was a fraction in that equation and not in the other ones, maybe avoid it. But other than that, I tend to always choose the one we solved for the variable to plug back into. And if I wanted to check this, what would I do? Plug it in. It has to work in both equations. All right, then you're going to get it mixed in. There's going to be decimals. There's going to be fractions. When there's a fraction, I would say eliminate the fraction. Multiply everything by the least common denominator, get rid of the fractions, and then go from there. In this case, where you've got decimals, I would recommend getting rid of the decimals. So what multiple of 10 would move all my digits to the right one for the top? 10. I multiply everything in the top by 10, and it moves every decimal to the right. I get 15x plus 8y equals 23. And same in the bottom, I only need to move it once, so I also multiply by 10. And I get 3x minus 2y equals 1. Now I got to isolate. So to isolate, I need to move around one of these equations so that it solves for x or for y. None of them are already by themselves. So no matter what you do, there's going to be movement and dividing. If there's like a negative, I can make positive. I tend to choose that. So like if you look at the bottom, if I add 2y, I get 3x equals 1 plus 2y, and then I'd have to divide everything by 3. So you can avoid it, and you could keep it like that, 1 plus 2y over 3, or you could divide it into each one. 1/3 plus 2/3 y. You could use either of these when plugging back in. I have to plug it back in to the one I didn't use initially, so the 15x plus 8y equals 23. So I'm plugging it into that x. 15 times 1 plus 2y over 3 plus 8y equals 23. 3 goes into 15 5 times. I got rid of my fraction. Now I can distribute 5 plus 10y plus 8y equals 23. 5 plus 18y equals 23. Subtract the 5, 18y equals 18. Divide by 18, and y is 1. And now I got to plug it back in. Again, I can go to either of the originals, or I could go to the one I solved for x. If the fraction throws you, then go to the original. Like I would have gone to the original that says 3x minus 2y equals 1. If you want to avoid the fraction. But if not, if I plug it in here, x equals 1 plus 2 times 1 over 3. 1 plus 2 over 3, 3 over 3, which is 1. And I put it in coordinate point form, 1, comma, 1. Do not freak out if you get a decimal. Like you can get a decimal. It shouldn't be something weird like 1.78623 or something like that. But you can get a decimal for these or a fraction. No, because, good question. Because we changed the entire equation, you don't need to then correct it. If you only change part in equation, that's when you got to change it back. But because we changed the whole thing across the board, that's fine. You could leave it like that. Yep. Any other questions? All right, now we're going to solve by graphing. Probably everybody's least favorite, but if the quiz, and it will, says solve by graphing, you have to. You can use another method to check it, but you have to solve whatever way it tells you to. So when you're doing these homework questions and it says solve by graphing, you need to make sure you have the graph to back your answer choice. So you're going to graph each line. These again, we're starting linear. We're going to graph the lines. We're going to put them into slope or point slope, or no, slope intercept, like y equals mx plus b. And then where the lines intersect is your solution. There are two special cases. If the lines are parallel, they will never intersect. So there is no solution. And if they overlap, meaning you end up with the same equation, every single point would overlap, which means it's an all real number scenario. God bless you. All right, so example 4, solve the system by graphing. First thing I got to do is get these into slope-intercept form. So I'm going to solve for y. I'm going to get them into y equals mx plus b form. So if I take this first one, I can subtract the 3x. I get negative 2y equals negative 3x plus 7, and then divide by negative 2. Make sure you divide each part by negative 2 all the way across. And I get y equals 3 halves x minus 7 over 2, which is going to get graphed. So that's negative 3 1/2. You want to convert it to a mixed number or a decimal. That's going to be the first one I graph. So I go to negative 3 1/2. I plot a point because that's my y-intercept. And then I count up 3 and to the right 2. So 1, 2, 3 to the right 2. Or I could count down 1, 2, 3 and to the left 2. It doesn't matter which direction you go in. And sometimes when you go to graph, you'll see either you run out of room in one direction or the line is the other direction for the other one. So it just makes sense to go one way over the other. It doesn't matter which way you go. Then I go to the next one. I'm going to now solve that one for y. So I subtract the 6x. Negative 4y equals negative 6x, God bless you, plus 9. Divide everything by negative 4. And I get y equals 3 halves x minus 9 over 4, which is 2 1/4. Well, negative 2 1/4 would be the b. Now I'm going to graph that one. What do you notice about their slopes already? They're the same. What does that mean? Good. If I have the same slope, different b's, they're parallel. If I have the same slope, same b's, now what? Same equation, all real number. Okay. So this one, I'm going to plot 2 1/4, negative 2 1/4. And then I'm going to count my slope up 3 over 2. 1, 2, 3 over 2. Down 1, 2, 3 over 2. Either way, these lines are parallel. They never intersect, which means this is no solution. What changes with 5? What's there that we haven't had yet today? X squared. What is x squared graph? Parabola, okay? So this goes back to your parent functions, or if you don't remember, you plug in some points, okay? So I'm going to start with the line. I'm going to start with the top one. Subtract the x, so negative y equals negative x minus 4, and then divide or multiply by negative 1. Y would equal x plus 4. And I'm going to graph this one. I start at positive 4, my slope is 1. So I go up 1 to the right one or down 1 to the left one. And then draw your line. Then the second one we said has an x squared. If it has an x squared, that means it's a parabola. I'm going to isolate the y because that's what we were used to by graphing. If I move the y to this side, I have to move the 2 to this side. So add the y, add the 2, and I get x squared plus 2 equals y, or y equals x squared plus 2. We know parabolas look like this, right? What's the plus 2 doing? It's shifting it up 2. That's a vertical stretch. I mean a vertical shift. If you don't remember, plug in some points. And I would plug in the points related to the ones I have here. So I would plug in 0, I would plug in -1, and I would plug in +1. But if you remember your parent functions, it's going to make life a lot easier. This goes up to 2. I'd plot a point at 2. And then whatever's in front of the x squared causes a stretch or a shrink. If it's 1, that means there's no stretch or shrink. It goes up and out 1. So I go up 1 and to the left 1 and up 1 to the right 1. Now I already have that coordinate point. If I want to see where it's going to intersect on this side, I would keep plugging in a point until I find a cross. So I know what happens at 0. I know what happens at 1. I can plug in 2. So if I plug in 2, I get y equals 2 squared plus 2, or 4 plus 2, which is 6. So that coordinate point is 2, 6. 1, 2, 3, 4, 5, 6. And that is on my other line. So now I know it intersects 2 places. It intersects at -1, 3, and it intersects at 2, 6. Now we didn't use one of the questions, actually one of the questions we passed already said, like, use your graphing utility to verify. We didn't use it yet, but that would be to check your answers. You won't use a graphing utility on the quiz. You won't use a graphing utility on your test. So if I wanted to check this, I would literally go to my graph. I would go to my graphing calculator, go to my y equals and type in this sucker, go to my y equals and type in this sucker, and then use my intersect tool to see where they cross. We still good? Yeah? All right, this one says, solve the system using substitution. Write a graphing utility to verify your results. Now we've got a cubic function in here, right? Our cubic function has this like shape that looks like this. So if I were to graph it, I would solve for y and it would look like that. Actually, because it would be negative, it would be flipped. But it would have that general shape. But I don't need to graph it because it said I could use substitution. So pick one of these equations and solve for one of the variables. Top or bottom? Top. X or y? X. So let's solve this one for x. All I have to do is move the y. I would say you could solve top or bottom. Top, I could solve for x or y. It'd be easy. Bottom, I would not want to try to solve for x. You'd have to move the y, and then you'd have to cube root it. So I would avoid that if you could, okay? And this time we totally can. We can use the other one. All right, so now I get that x equals y. So in the place of my second equation, where the x is, I'm plugging y. And I get y to the third minus y equals 0. Then what? If I move the y, it's just going to go back and forth, right? If I add the y to the other side, I get y to the third equals y. I still can't do anything. I can't divide by y and eliminate it. So what do I do when I have to solve and there's something squared or cubed? Factor. What can you take out? A y. So I take out a y and I get y squared minus 1 equals 0. Is that factored completely? Nope. What else can get factored? Good. Y squared minus 1 is difference 2 squares. So this becomes y times y plus 1 times y minus 1. How many y's are there? 3. set this equal to 0, set this equal to 0, set this equal to 0, and I have 0, -1, and 1. That means there are 3 ordered paired combinations. One where y is 0, one where y is -1, and one where y is +1. So I'd have to plug those y's back into the equation, well, any of these. I'm going to pick the one I solved because that's super easy. The y equals the x. So this would be 0, 0, -1, -1, and 1, 1. We're going to go back to using the graphing utility. I want to make sure we make it through the notes, and then I'll come back and do this. But just prior knowledge tells us that y equals x is a line with a b at 0 and a slope of 1. So it would look like this. And solve this for y, and I get y equals x to the 3rd. So I'd go through the middle. I'd go up on the right and down on the left, and it would cross my graph at 3 points. 0, 0, -1, -1, and 1, 1. But again, we'll get a visual. We'll come back to it on our graphing utility. All right, so I went to my y equals. I plugged in each of these graphs. The square root is above the x squared button, if you can't find that, but that's there. And then I'm going to hit graph. Oh, my window is very strange. I'm going to set my window. It looks like yours. We do weird things in AP. And then if I want to find where this intersects, I go second, trace, which is the calculate menu. I go down to 5 where it says intersect. It's going to ask you 2 questions, first curve and second curve. It doesn't matter which one's which, as long as it's somewhere on that first line, which it is, like you can see the blue and you can see the point on the bottom. Anywhere along this line, just hit enter. Then it's going to switch to the other line, second curve, and I hit enter. And then it's going to ask if I'm ready to guess, and I say yes. And it takes you to the coordinate point in which they cross. So if there was 3 lines, let's say, and you wanted to know where 2 of them were, then you would isolate those 2. So if you are using this to check your answers, fantastic, do it. But realize that graphing calculators are not going to be able to be used on the test. So the coordinate point here, or the answer 2.25, 5.5. And it says verify by checking your results in your original system. I would use the calculator because you'd be square rooting 2.25, but I could use that. Square root of 2.25 plus 5 plus 4 is going to give you 5.5, and 2 times 2.25 plus 1 is going to give you 5.5. Questions on anything we talked about today? Okay. All right, now we got word problems. So this is where obviously we hate systems of equations. All right, these are not that bad though. So word problems are great standardized test questions. SAT, ACT love word problems involving systems of equation. You've got to set something up and then solve it. These are interest problems, okay, or this one. It says you're given a yearly interest earned from a total of $12,000 invested in 2 funds paying the given rates of simple interest. Write and solve a system of equation to find the amount invested at each rate. Simple interest means literally I just have to take the money that's in there and multiply it times the interest earned. So if I'm earning 3%, I convert that to decimal, and the money earned is 0.03 times the amount of money that was given. That's how you figure out simple interest. Not compounded a certain amount of times a day, which is your P times 1 plus R over N to the NT. We're not doing that. And this is not compounded continuously with PERT. We're not doing that. Simple interest means literally take your money that's invested and multiply it times the rate in decimal form. So I have $100 invested in an account and I'm earning 3% at the end of the year. I would have $3. But with this, they're given 2 things. They're given a rate at 3% and a rate at 5%. So you are investing money in one account that's earning 3% and you're investing money in one account that's earning 5%. Those are your two variables. So I can say X is the money invested in the 3% account, and I can say Y is the money invested at 5%. God bless you. So in the body of the word problem, it says you're given the yearly interest earned from a total of $12,000 invested in two funds. That means the total amount of money put into these two accounts equals $12,000. That means X plus Y equals 12,000. And that's one of your two equations. Then the other one involves the interest that's earned. So if it's earned, it earns $500 at the end. Then I would take the amount of money invested at 3% times 0.03 plus the amount of money invested at 5% times 0.05, and it should equal the amount of interest earned, which is 500. So 0.03x plus 0.05y equals 500. Now you have a systems of equation. So when we do 7-2, we're going to do elimination. I would actually treat this as elimination, and I would change them and add them. But for now, we're going to focus on substitution. So which of these equations would be easier to solve for a variable? Top, for sure. Does it matter which variable? No, they both have the same moves. So let's just say x equals 12,000 minus y. Then that goes into my bottom equation in place of the x. Now, before I do that, I can get rid of those decimals. What would I have to multiply everything by in that second equation to get rid of the decimals? 100 this time because I got to move it 2 decimals. Be careful and make sure you go all the way to the other side of the equal sign. So this becomes 3x plus 5y equals, I have to tack on 2 more zeros onto that 500, so it becomes 50,000. Now I can take the x and plug it in. 3 times 12,000 minus y plus 5y equals 50,000. Distribute, I get 36,000 minus 3y plus 5y equals 50,000. Combine my like terms, 2y, subtract the 36,000. I get 2y equals 14,000, divide by 2, and y equals 7,000. So 7,000 is the amount of money invested at this 5%. 7,000 at 5%. How do I find out how much was invested at the 3%? I can plug it back in, and the easiest place is the one I solved for x. The total investment was 12,000, so if I invested 7,000 at the 5%, 12,000 minus 5,000, or sorry, 12,000 minus 7,000 equals the 5,000, which was the amount invested at 3%. Questions? So on this quiz, I will allow you to use scientific calculators only, okay? You cannot use a graph. I mean, you can't use a graphing one because one, you could graph the answer. And two, when we get into matrices, you can't because a lot of them are matrices capable. So if you want to go home and see if you've got one of those scientific calculators, or if you know a friend that has scientific calculators, you can start to bring it. Because that would be much easier if I could have done that with my scientific calculator, right? And these numbers are going to get sometimes they're weird. All right, last word problem is break-even analysis. So a break-even, actually, sorry, there's one more after this. Second type. The break-even, let's say you're starting up a company, right? Little entrepreneurs. What would we want to sell? What could you sell? What would make you money? Shoes. Okay, we're going to sell shoes. So the break-even point is when the money that you spend producing those shoes, okay, equals the amount of money that you're bringing in. So in these, they sometimes will actually have you come up with your own cost function and your own revenue function. In this case, it gave it to you, or I gave it to you. But if you had to come up with, like, each shoe costs you blank amount of money to make, plus you have an upfront cost, like however much you had to, like buy the shoe making machine, okay? Could be your upfront cost. So like that would be like, it costs you $200,000 or $250,000 to buy the machine to make the shoes. Then it costs you $8,000, these are very expensive shoes, $8,650 for each pair of shoes that you make. That's your cost function. The revenue is how much you're selling those shoes for. So this, again, very expensive shoes, but $9,950 per shoe, okay? And your cost or your break even is literally when they equal each other. So you don't even have to do substitution here. You are saying you want C to equal R, so we are blending these two together. And we're saying we want 8,650X plus 250,000 to equal 9,950X. And then solve. So subtract the 8,650. And then divide. So I can cancel out my zeros, and I can do 13 into 2,500. And again, this is like when it would be easier with you can do it without, but it would definitely be easier with a scientific calculator. So I get 192.3076, whatever, and so on. So now think about a break even. How does 192.3 normally round? One, I can't sell 0.3 of a shoe, right? So I would normally round that number down, and I would round it to $192. If you sell 192 shoes. If you sell 192 shoes, have you broken even? No. So break even analysis, you always round up. Even if it was like 192.09, you still have to round it up because you always have to sell enough to then go more, right? So if I round down, I'm in the negative. I have to round these up. Unless you can sell like partial of something, which most items you cannot sell partial of. So this is going to be 193. However, whatever the items are, that's how many units you need to sell. If it said, what price would you be charging? Now I'd be taking the 193 and I'd be plugging it back in, and I can plug it back into either one. Or how much money would you have to make? Not necessarily what are you charging, but how much money do you break even? Then you can plug it back into either of those to find out. But this question just literally says find the sales necessary to break even by selling X amount of units, and that is what you're looking for, the number of units. Still good? Yes? Okay, now for sure the last one. So again, systems of equation, you'll see word problems dealing with perimeter, you'll see word problems dealing with area, you'll see word problems dealing with lots of different situations, okay, in which you can set up a systems of equation. So this one says the perimeter of a rectangle is 30 meters and the length is 3 meters greater than the width. Find the dimensions of the rectangle using a systems of equation. So first thing I need to know is perimeter. How do I find the perimeter of a rectangle? That's area. What's perimeter? Add up all the sides. If I wanted it in terms of length and width, it'd be, how many lengths are there? How many widths are there? So it's twice the length plus twice the width. That's perimeter of a rectangle. That's the first equation. Then the second is they will give you some sort of relationship between the length and the width. In this case, it says the length is 3 meters greater than the width. So length equals 3 meters more than the width. It could say the length is twice the width. It could say the length is 5 more than twice the width. Either way, you have some sort of relationship to set it up. So what else they told you is that the perimeter equals what? 30. So P is 30. If I left it as it is, I had 3 variables. That's too many. We're doing 2. So now I already have this set up for substitution. I can take the length and I can plug it in here. Or sorry, not there. And plug it in here. And I get 30 equals 2 times 3 plus W plus 2W. 30 equals 6 plus 2W plus 2W. 24 equals 4W. And W is 6. That's the length. I'm sorry, that's the width. Now I need the length, so I plug it back in here. The length is 3 plus 6. The length is 9. So this is 6 meters by 9 meters. Or the length is 9 and the width is 6. You could do it that way. It doesn't matter. Those are the dimensions.